Hello, everyone. Today I will present YOLOv5 and YOLOv8 architectures. Now let me start with YOLOv5. YOLOv5 is quite similar to YOLOv4 architecture, and it has three main parts: backbone, neck, and head. As backbone, they're using ASP Darknet 53, which is named as cross-stage partial network. PINet in the model neck, which is path aggregation network, which is exactly the same which was used in YOLOv4. And as a head, they use the same convolution layer as used in YOLOv4 and YOLOv3. So as it can be clearly seen, the main difference between YOLOv5 and all previous models are CSP network, which is cross-stage partial network. As you can see here, authors use CSP to partition the feature map of base layer into two parts, and then each of them passes different layers. This one is the details of one stage layer, which was used in YOLOv5. They apply usual convolution model, and then it goes to CSP network, which gets feature maps, then splits into two. One part is passed through a convolution model and dark bottleneck, and then another one just passed via convolution model, and then they're concatenated. So what was the big advantage of it is that CSP network implemented with Darknet 53 allows to reduce the number of parameters and help to reduce important amount of computation, so that it increases the inference speed compared to previous models. So now, if we come to model neck part, it can be seen that mainly model neck part is used to generate feature pyramids, and it helps to generalize on object scaling so that we will differentiate between different sizes and scales. As main part of neck, authors use PINet, which is the same as in YOLOv4, path aggregation network. And as you can see here, it mainly consists of these parts. So it's using convolutional model and some layers, and then concatenates everything from each stage layer 2, stage layer 3, and so on. In YOLOv5, this network also has been modified by applying CSP-net strategy, as you can see here. So in YOLOv4, there was no CSP layer in the PINet architecture, but then it now exists in YOLOv5 architecture. And if we come to the head part, it uses the same head as YOLOv3 and YOLOv4. It mainly consists of 3 convolutional layers, and as you can see here, so this one, convolution 2D, it consists of 3 convolution layers, and it's used to make a prediction of location of bounding box, the scores, and the object classes. Okay, that is the main advantage and the main difference of YOLOv5 from previous models. Now let's go to YOLOv8 architecture. YOLOv8 architecture was similarly created as YOLOv5 by Ultralytics company. Unfortunately, there is no paper on it, but there is clearly illustration of how YOLOv8 architecture looks like. So it uses the same, almost the same architecture as YOLOv5, but the main difference is that instead of CSP layer, which was introduced by me in previous slides, now they use C2F model. C2F model is cross-stage partial bottleneck with 2 convolutions. So as you can see, there's only one convolution model, and there is only split into 2 parts, while this one is how C2F layer looks like. So they have feature maps, then they are split in several parts, and for instance, one part goes through one bottleneck, then another part goes through another bottleneck, and then all of these features by concatenating to different paths are concatenated in one, and then pass to the next convolution layer. So this is the main advantage of YOLOv8 architecture. As you can see here, here, the same as in YOLOv4 or YOLOv5, they have bottleneck, which consists of several convolution layers. They same have SPPF, which is also this type of convolution layers combined with multiple 2D layers. And by using C2F instead of CSP layer, it allows actors to increase the inference speed. And also, one of the main advantages of YOLOv8 is that it's anchor-free detection. So it doesn't require for users to specify anchors before running the model, so that it will generate exactly right away bounding box without having specified predefined anchor boxes before. Also, in YOLOv8, there is DFL loss function introduced for bounding box loss. It's interpreted as dual focal loss. As I have searched and understood, dual focal loss is responsible for class imbalance problem during object detection. This is the formula of dual focal loss. And this loss has improved object detection performance, particularly when detecting with smaller objects. So in spite of YOLOv8, there's also other architecture models like YOLONAS and so on. But considering with YOLOv5 and all previous models, YOLOv8 has more advanced and well-defined architecture. And it tends to get a higher inference speed than previous models. Thank you for your attention.